Hello friends, our today's topic is Coulomb's law. Yesterday we have studied about point electric charge and various charge distributions. Coulomb's law is applicable to point electric charges and not to charge distributions. For that we have Gauss law. Gauss law is applicable to charge distributions. Today we are to discuss about Coulomb's law. What is the statement of Coulomb's law? Mutual force of attraction or repulsion between two point electric charges in vacuum is directly proportional to the product of the charges and is inversely proportional to the square of the distance between them, and direction is along the line joining the charges. I repeat, mutual force of attraction or repulsion between two point electric charges in vacuum is directly proportional to the product of the charges and inversely proportional to the square of the distance between them, and direction of the force is along the line joining the charges. Here you can see these are two charges Q1 and Q2 which are both positive. Here both are negative charges. The force will be repulsive in both cases. Now here plus Q1 is positive and minus Q2 is negative. So force of attraction will be attractive. This is how we say statement: mutual force of attraction or repulsion between two point electric charges in vacuum is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Direction is along the line joining the charges. Now mathematical expression. In mathematical expression we consider two point electric charges Q1 and Q2 separated by distance r in vacuum as shown. Separated by distance r in vacuum as shown. Let F be the mutual force of attraction or repulsion between them in vacuum, then F is directly proportional to the product Q1 Q2 and inversely proportional to distance square. F proportional to 1 by r square, and here F proportional to Q1 Q2 product and F proportional to 1 by r square, which is inverse proportion. Now we proceed to the combination of the two. If we combine the two statements written above, then we say F is proportional to Q1 Q2 divided by r square. We remove sign of proportionality and introduce equality. F is equal to K naught Q1 Q2 by r square. Now where K naught is constant of proportionality and is given by the expression K naught equal to 1 by 4 pi epsilon naught, where epsilon naught is equal to 8.85 into 10 raised to power minus 12 Coulomb square per Newton per meter square and is the absolute permittivity of free space. On substituting the value of epsilon naught, we get K naught equal to 9 into 10 raised to power 9 Newton meter square per Coulomb square. Now direction. We talk of direction. Direction of the force is along the line joining the charges. Okay. Now discussion. We come to discussion of the formula. Now in discussion we take our first point: when product Q1 Q2 is more than 0, that is positive. Charges are similar. Nature of force is repulsive. And number 2, when the product Q1 Q2 is less than 0. When product Q1 Q2 is less than 0, that is negative, then charges are opposite in nature and nature of force is attractive. Now, third point, when R approaches infinity, force becomes 0. Now, fourth point, when R becomes half, force becomes 4 times. And fifth point, when R becomes double, force becomes 1/4. You can calculate by substituting the values of R. Now, sixth point, when system of charges is placed in a medium of absolute permittivity epsilon A, then FA is equal to Ka Q1 Q2 by R square. Now we replace Ka by 1 by 4 pi epsilon A Q1 Q2 by R square, and then it is equal to 1 by 4 pi epsilon A epsilon R, because epsilon A is equal to epsilon naught epsilon R. So we can replace Fa by 1 by 4 pi epsilon naught epsilon R, which is equal to 1 by 4 pi epsilon naught here. We can replace by K naught here, and we get Fa is equal to K naught by epsilon R into Q1 by Q2 into Q1 Q2 by R square. And then finally we write K naught Q1 Q2 by R square is equal to F naught, and then divide by epsilon R. So Fa is equal to epsilon F0 divided by epsilon naught, epsilon R सब गलत हो गया. We carry out discussion once again. तेरे की सब गड़बड़ हो गया. Now discussion. We know F is equal to K naught Q1 Q2 by R square. Take up first point, when product Q1 Q2 is more than 0, that is positive, charges are similar, nature of force is repulsive. Second point, when product Q1 Q2 is less than 0, that is negative, charges are opposite in nature and nature of force is attractive. Third point, when R approaches infinity, force becomes 0. Now fourth point, when R becomes half, force becomes 4 times. When R becomes half, force becomes 4 times. Fifth point, when R becomes double, force becomes 1/4. So you can calculate by substituting the value of R. Now sixth point, when system of charges is placed in a medium of absolute permittivity epsilon A, then Fa we can express Fa equal to Ka Q1 Q2 by R square. We replace Ka by 1 by 4 pi epsilon A here. So we have Fa is equal to 1 by 4 pi epsilon A Q1 Q2 by R square. Now we replace epsilon A by epsilon naught epsilon R here. So we have Fa is equal to 1 by 4 pi epsilon naught epsilon R into Q1 Q2 by R square. Now we replace 1 by 4 pi epsilon naught by K naught here. So we have Fa equal to K naught by epsilon R into Q1 Q2 by R square. Now we know K naught Q1 Q2 by R square is F naught. So Fa becomes F naught by epsilon R. Thus, in a medium where epsilon R is the dielectric constant of the medium, the force in medium reduces by a factor equal to dielectric constant of the medium. Okay. Now we come to SI unit of charge. SI unit of charge is Coulomb C, and we define Coulomb. Definition of Coulomb we require. Now, since we know that magnitude of mutual force of attraction or repulsion between 2-point electric charges in vacuum is given by the expression F equal to K naught Q1 Q2 by R square. Now, when Q1 is equal to 1 Coulomb, Q1 is equal to 1 Coulomb, Q2 is equal to 1 Coulomb, and R is equal to 1 meter, then F is equal to 9 into 10 raised to power 9 Newton. Thus, Coulomb is defined as that charge which, when placed in vacuum at a distance of 1 meter from an equivalent similar charge, repels it with a force of 9 into 10 raised to power 9 Newton. Or Coulomb is that charge which, when placed in vacuum at a distance of 1 meter from equal and opposite charge, attracts it with a force of 9 into 10 raised to power 9 Newton. Now, assignment 1.2. Calculate Coulombian force between two alpha particles separated by a distance of 3.2 into 10 raised to power 15 meter. Question number 7. Force of attraction between 2-point electric charges placed at a distance d apart in a medium is F. What distance apart should these be kept in the same medium so that the force between them becomes F by 3? Question number 8. 2-point charges Q1 and Q2 are placed close to each other in air. What is the nature of force between them when Q1 Q2 is more than 0 and when Q1 Q2 is less than 0? Now, assignment 2 continued. Question number 9. A comb drawn through a person's hair on a dry day causes 10 raised to power 12 electrons to leave the person's hair and stick to the comb. Whether the force between the comb and the hair is attractive or repulsive. B. What is the magnitude of the force when the comb is 1 meter away from the person's hair? Question number 10. Two identical charged copper spheres A and B have their centers separated by a distance of 50 centimeter. A. What is the force of electrostatic repulsion if charge on each is 6.5 into 10 raised to power minus 7 Coulomb? Radii of spheres A and B are negligible as compared to separation between them. B. What is the force of repulsion if each sphere is charged double the above amount and distance is halved? C. What is the force of repulsion if the two spheres are placed in water, given dielectric constant of water is 80? Okay, so these are the questions you have to solve on the text that you have learnt, on the basis of the text that you have learnt. Now we come to another term, absolute permittivity of medium. Now, what is absolute permittivity of free space? First, we understand absolute permittivity of free space. The property of free space to allow electric field lines to pass through it is defined as absolute permittivity of free space. Its value is constant and is given by epsilon naught equal to 8.85 into 10 raised to power minus 12 coulomb square per Newton per meter square. Now, absolute permittivity of medium. The property of a medium to allow electric field lines to pass through it is defined as the absolute permittivity of a medium and is given by the expression epsilon A equal to epsilon R epsilon naught, where epsilon R is the relative permittivity of the medium or dielectric constant K of the medium, which is different for different medium. Now we define relative permittivity of a medium epsilon R or dielectric constant of a medium. The ratio of absolute permittivity of a medium to absolute permittivity of free space is defined as the relative permittivity or dielectric constant of the medium. Okay, mathematically expressed as epsilon R equal to epsilon A divided by epsilon naught. Now SI unit. Being ratio of same physical quantities possess no units, because epsilon A and epsilon naught have are the permittivities, so they possess same units. So being ratio of the same physical quantities, it possess no units. Its value is different for different materials. For example, for air epsilon R is 1 and for water epsilon R is 81. Now we come to assignment 1.2. Question number 1. Calculate absolute permittivity of air. Number 2, of water. Question number 12. Define dielectric constant of a medium in terms of electrostatic force between 2-point electric charges. Question number 13. The electrostatic force between 2-point electric charges is F naught. How does this force change when the charges are placed in a medium of dielectric constant 81, same distance apart? Okay. Now, on the basis of the text that you have learned, you have to solve these questions or prepare your notes, whatever you want. You do it. Thank you so much. Thank you once again.